All right, welcome back. So we're going to do another one. We're going to solve this time. So we're going to solve via series y double prime plus omega squared y equals 0, where we're going to say y of 0, let's call that a 0, or let's not use a 0, let's call that y 0, and y prime of 0, we're going to call that y0 prime. So we're going to assume that these things are given, okay? All right, and we could, of course, solve this. You know how to solve this. I won't go ahead and get into the solution, but let's do it via series now. So we're going to assume that we have a solution y of x equals the sum, n goes from 0 to infinity, a sub n, x to the n. Now in this one, we're going to actually need the second derivative. Okay, we're going to need the second derivative here. So, sorry about that. So we're going to take y prime and y double prime. So y prime of x, just like before, is a sub n times n, x to the n minus 1. Y double prime of x is, again, sum, n goes from 0 to infinity. Now it's going to be a sub n, n times n minus 1, x to the n minus 2. Okay? Now, we could do the little shift with both of them, but we don't need y prime really. So we only really need to shift y double prime. Okay, so let's go ahead and do the shift on y double prime. So the first thing to notice, if n equals 0 or n equals 1, we're going to get 0, right? Okay, so I could write this immediately without anything crazy going on. No shift. A sub n, n minus 1, x to the n minus 2. Okay, and the reason again is because when n equals 0, this term is 0. When n equals 1, this term is 0. Now we're going to shift. We're going to shift because what we want is we want the exponents to match. Okay, we're going to write this in terms of x to the n. So this is going to be, let's sum, n now goes from 0 to infinity. And the way I think about this, okay, is I always think, what's my first term? My first term here should be a sub 2. Okay, so that means I'm going to need a sub n plus 2. All right. This term here, when n equals 2, that's going to be 2. So instead of n, it's going to be n plus 2. All right. Similarly, this term, when n equals 2, is going to be 1. So I'm going to need that to be 1. So I'm just going to put in n plus 1. And now I can write x to the n. Okay? So far, okay. So this is my expression for y double prime of x. Okay, let me write my equation again. Okay. So, again, we're going to write y double prime plus omega squared y equals 0. So, the sum, n goes from 0 to infinity, a sub n plus 2, 2, n plus 2, n plus 1. That has an x to the n, so I'm going to join it with the plus omega squared a sub n x to the n equals 0. Okay, so our recurrence relation, is just, again, at each n, the coefficients. Okay, so it's going to leave us with an plus 2, n plus 2, n plus 1, plus omega squared a sub n equals 0. Okay, so that's our recurrence relation. Now we're going to put, and we want to get a sub n plus 2 basically in terms of a sub n. So a sub n plus 2 equals negative omega squared a sub n, n plus 2 times n plus 1. So this is our recurrence relation. Okay, now we're going to construct our solutions from that. Okay, again, let's take a look at our y of x. Oops. Our y of x is up here. Let me write it down. Or let me write it down here. So let me go here in orange. And so y of x equals the sum, n goes from 0 to infinity, a sub n x to the n. Again, at n equal, where x equals 0, that means we're just going to be left with the a sub 0 term, right? So a sub 0 equals y0. Okay. Now, what about that y prime? That's going to come from here. Okay. So y prime of x, I'm going to write it shifted. Let me move this down a little bit. Sorry about that. Okay, my y prime of x, if I write it shifted, okay, that's going to be the sum, n goes from 0 to infinity. Let me write it shifted. So the n equals 0 term is out. So I'm going to write a sub 1, okay, n plus 1, x to the n, okay. Oh, sorry. That should be a sub n plus 1, but you get the idea. Okay, so what's the important thing here? The important thing here is that y prime of 0, okay, at 0, everything is going to go away as well, except the n equals 0 term, okay? N equals 0, so that's going to be 1 times a n plus 1. So a sub n plus 1 equals y prime of 0. Okay, all right. Oh, that should have been a sub 1. Right? Because when n equals 0, we're just left with a sub 1. Okay, I should have been an plus 1 at n equals 0. Okay, all right. Moving along. Okay, so now, why do we need 2 of these things? Well, we need 2 of these things because this is actually going to skip them. Okay, so let's go ahead and start. A sub 0 equals y0, and I'm going to write a sub 1 equals y0 prime. A sub 2 equals negative omega squared a sub 0 over Now here, when I'm thinking about this, this is n equals 0. So I'm going to need 2 and 1. Let's write it like that. 2 times 1. What about a sub 3? A sub 3 is going to be negative omega squared a sub 1 divided by, remember here this is n equals 1, so that's going to be, what, 3 times 2. Okay, let's go further along. A sub 4. A sub 4 is going to be negative omega squared a sub 2 over, now, a sub 4, remember that is n equals 2, so that's going to be 4 times 3. Which is now, that's going to be, these negatives cancel, so it's going to be positive omega to the 4th. Oh, a sub 0 was y0, sorry about that. Okay, a sub 2 has a y0 divided by, let me just write that as 4 factorial. Okay, a sub 5 is negative omega squared a sub 3 divided by, now this is, remember, 5, that means n equals 3, so that's going to be 5 times 4. Let's write that as 5. Oh, 5 times 4. Substituting, again remembering, this time I'll just do it this way. A1 is y prime, I'm sorry, y0 prime. This is going to be positive omega to the 4th a to the, I'm sorry, y0 prime 5 factorial. Okay, I think I made, nope, I'm okay. Let me just check something real quick. Got it. I know my problem now. Okay. All right. We're starting to see a pattern, right? Okay, so for the evens, a sub 2n is going to be negative 1 to the n. Okay, so here this is n equals 1, n equals 2, positive, so we've got the right signage. Okay. Omega to the 2n, okay, over 2n factorial y0. So that's for the even ones, okay? For the odds, a sub 2n, let's say plus 1. Okay, let's make sure we have the signage right. So this is n equals 0, this is n equals 1. So negative 1 to the n. Okay, I'm just making sure. So what I'm doing here is the typical thing. So for n equals 1, I need it to have a negative. So that's why it's this way. Okay, it could have been n plus 1, but just had to make sure that it checks out. This is n equals 2 plus, that'll check out. Okay, we get omega to the 2n, okay, divided by 2n plus 1 factorial y0 prime. Okay, so now let me move this up just a little. Our solution is then y of x equals, I'm going to write it in two different pieces. N goes from 0 to infinity. This one's going to be negative 1 omega to the 2n over 2n factorial y0 plus some n goes from 0 to infinity, negative 1 to the n omega to the 2n over 2n plus 1 factorial. Oh, sorry. I should have, of course, an x to the n here. Actually, x to the 2n. And here I have y0 prime x to the 2n plus 1. Okay? So now, how does this connect with sine and cosine? Well, remember the Maclaurin series for sine and cosine. This is y0 cosine omega x. Okay? Plus, this is y0 prime divided by omega of the sine of omega x. Okay? Remember, we needed the plus one, so what we're really doing is we're going to plus an omega here, or plus an omega there, and divide by an omega there. Okay? And that's how we'll get the sine function. Okay? All right. I'll see you all in the next video.